Hello, everyone. Welcome to Wind Down Friday. Today, our guest is Steven Oliver, Vice President of Corporate Marketing and Investor Relations at Navitas Semiconductor. Hi, Steven. How's it going?
Hello, Maurizio. It's going great. Thank you.
Good. Where are you located now, Steven?
This is just north of Boston in east coast of the US. So I've
Good.
traveled around quite a bit from the UK to the US and then international travel. But Boston is now home with my wife and two kids.
Great. So, Steven, let's talk about you. You you have 30 years of experience in semiconductor power, semiconductor industry, more or less, maybe more. So let's talk about you. Give us a little bit of yourself and the background information.
Okay, yeah, 30 years. Um, so I'm from Newcastle in the north of England. It's a traditional heavy industry area. So my grandparents were in coal mining, steel making, ironwork, um, and so that gave me a straight into engineering viewpoint. You can't escape railways, you can't escape electrification, you can't escape the kind of engineering breakthroughs. Um, from there, I went to Manchester University in the UK to do power electronics, and then couldn't really get a job at the time. I came out in 91, 92, and it was a tough period. So I did some work working in pubs. I sold newspapers. I did lots of other things. Eventually, I got a job with Motorola that became part of Continental. It was the automotive division. Starting in the quality team, actually. So I'm a Six Sigma black belt, if anyone has those stats. And from there, I went to Philips in Manchester, UK, which became NXP. And then I was working in Manchester, and someone said, would you like to work in Los Angeles? And I thought, there's rainy Manchester or there's sunny Los Angeles by the beach. So, okay. And I ended up at International Rectifier in El Segundo, which is actually where I met a lot of the founder members of Navitas that I'm working with today.
Mhm.
Um, really uh, pretty life-changing experience coming from the UK to the US. Life is different, especially the West Coast. Was able to progress in the career, continue to do a lot of travel, exploring China, exploring Taiwan, exploring Europe. Then I got a job working for Vicor, the power supply company in Andover, just north of Boston. And that's where I kind of settled down. That's where I met my wife, and this is now home. So it's
Mhm.
been a long journey, a lot of plane miles, um, but now it's time to really, settle down and maybe focus on family also.
So we talked a lot about gallium nitride, silicon carbide, electrification.
Mhm.
So talking about the Navitas devices. So with your background, so which trends do you foresee in the power semiconductor industry, maybe in the future?
Mhm. Yeah, there are definitely things happen in waves or in revolutions. So for silicon in power, obviously the late 70s, early 80s was a transition from
Mhm.
bipolar to the switching MOSFET. And I kind of was part of a kind of mini wave within that, with the introduction of the low voltage trench silicon with Philips. And then you realize that silicon's running out of steam. You can't get blood out of a stone. So then you look at new materials. And so with silicon carbide, I think entering the market around 2000, 2001, with the diodes and with GaN really coming into maturity in 2010, 2015, there's a new generation. And it's not really just the power device that's changing, it's the family around it. So if you have a really high speed, high voltage device, you need high speed, high voltage ferrite material. You can't rely on the old 50 hertz stuff. You need to, go into the 2 megahertz range. And then you look at wider in the industry as well, and you think, well, okay, now the power's there, so you can fast charge something, but can the battery take it? And so we're seeing right now the evolution or revolutions in battery technology, where you've got graphene lithium ion coming in that can handle more power, stay cool without any lifetime wear out mechanisms.
Mhm.
And then you look at new topologies and techniques. So the first mass production charger using GaN was in 2018, and that used the active clamp flyback topology. And that was a topology that was actually, I think, patented at Virginia Polytechnic back in 1995, 1996. But it couldn't become reality until you had a GaN power IC from Navitas to do that. And also TI, thank you to TI for bringing out a control chip that worked with it. And we used Hitachi ML95S material, for the ferrites. So you've got this whole thing. And so things come in waves, and a lot of times, with a nod to the Italians, there's the Leonardo effect. So Leonardo da Vinci invented the helicopter on paper, but he was dealing with string and wood and cast iron. He couldn't make it fly. But if he had today polycarbonate materials and micro engines and all of this advanced technology, I'm sure he would make it work. So we've got a lot of great ideas that are waiting for their time, and that time is now.
So when you are working in this on this field, skills are important. So like engineers. So could you describe a project or event from your life or professional lives that gave you important skills, life skills that you still use now today?
Yeah, I think one of the important skills is when you have a problem, when you have a
Hmm.
setback, you have a failure, to think, well, what can I do? How can I improve? And there have been several times where you're working on an amazing project, but it doesn't quite work. You need another spin of a PCB or a mask set. And working with the customer is critical, making sure things are transparent. So, up front, we're always dealing with new technology. It's all leading edge, but we don't want bleeding edge. We want to move this thing forward. So there are times where you're working with something new and a customer wants to drag it from your hand, and you need to be transparent and say, if everything works well, if the stars align, we just had an eclipse, then it'll work, but don't bet on it. And so by being transparent, if there is a setback, the customer knows about it, they can deal with it, and there's always a plan A and a plan B, maybe a plan C. So not everything runs smoothly, but you can still hope for the best. And that hoping for the best means that there's a chance, if you work hard and things work well, you can achieve amazing things in a short time. But maybe as an engineer, just as a scientist, you need a backup plan as well. So looking at the chances of something happening, making sure everybody on the team is on the same side, pushing in the same direction. And that team is not just the company you work for, it's the customer, it's the supplier, it's the partner. Everyone has to be on the same page moving forward.
So let's switch in science fiction. So let's play. You mentioned Leonardo da Vinci. So let's talk about I was saying physics, but this is not physics. So if you could travel to any time in history, so back to the past, back to the future, like the movie. So what would you do?
There's an amazing period of time for science and engineering, and that's around about 1900 to 1910. In the UK, it's called the Edwardian era, named after the king. Um, in that time span, that 10 years, you had uh, the most powerful railway locomotives in the world built in Newcastle or in the US by the Baldwin Works. You've got these amazing powerhouses of the Industrial Revolution. You've got some of the most amazing ships in the world. You've got Tesla's first patent in the US. You've got the Wright brothers with their first powered flight. This 10-year period between 1900 and 1910 in the engineering world is just amazing. So I'd like to travel back to that time and be able to jump around country to country to find out what's happening. Now, it wasn't a perfect time. If you were poor, you were really poor. You know, working conditions in the factories were not good. Um, so I can't make sure I can't claim it's a rosy period in time for everybody, but on the engineering side, it was amazing for revolutionary breakthroughs.
Outside of work, beyond of your job, so tell us which are your hobbies. So what are your interests that contribute to your work-life balance? So do you have planning for the next weekend with your family? Book. So which type of book do you like to read? Watch. So football, soccer. I guess you like soccer.
I do. I like football using the world terminology. So yes, being born in Newcastle, I'm a Newcastle United supporter, which makes me a Geordie in the local language. Um,
Newcastle, Alan Shearer.
the Alan Shearer, yeah, back in the day, yes. So yeah, big supporter of Newcastle. My dad first took me when I was maybe 7 or 8. I tried to follow them when I was a student. The way it worked out, I was working in Manchester, or studying in Manchester, and I
Mhm.
couldn't afford to go back to Newcastle every weekend. But from Manchester, you can go to Manchester United, Manchester City, Oldham, Bolton, Blackburn in a very close area. So I think I saw more away games than I did the home games. And I've always followed football, soccer. I managed to go to the World Cup in South Africa with some friends. That was a great experience as
Nice.
well, mixing with all of the countries and having a great time. So soccer, I try and watch that as much as I can. Um, Obviously, the family, taking care. I've got two little girls. They're twin 10-year-olds or 10 and a half, daddy is what they say. So they keep me busy. We did get away last weekend. We had a really good snowfall just north of Boston. So um, went up with the family. We've got 3 snowboarders, and one of my little girls is a skier. So we enjoyed the last of the snow. So that was good. Um, Sunday morning, I will be playing soccer. There is an over 50s league. It's called the Over the Hill Soccer League. Everybody turns up and does their best. Usually the team with the most substitutes wins because you roll in, roll out. So that's fun. In terms of movies,
Mhm.
TV, been watching a lot of kind of documentary movies. There's been one
Okay.
uh, in the US recently called Manhunt, which is about um, Lincoln and the end of the US Civil War, which for me is actually a learning experience because in the UK, you don't really learn about the American Civil War, but being here, um, you really learn more about it. And actually, when I moved from Los Angeles to Boston, I took 2 weeks and drove across country and managed to see some really cool, you know, geological formations, so the Grand Canyon, so the Carlsbad Caverns, but also went through Gettysburg as well to learn more about the history. So that's quite cool. But at the same time, I like classic movies like Highlander
Mhm.
or Die Hard. So if there's a boring part of time and I've got 10 minutes to kill, I'll probably watch something I've already seen 10 times.
Nice. So you mentioned World Cup, but after PCIM, there is the European Championship this year.
There is, yes, it's going to be an interesting experience. I won't be able to see it live, but I'll be watching on TV, whether it's, you know, 4
Yeah.
a.m. in the morning for me to catch a game. I'll still be there, and I'll drag the girls up to watch me as well, to watch the game as well.
Good. So Steven, in conclusion, my last question. So talking about to new professional or young professional, so what advice would you give to professional, to people aspiring to lead in the field of power electronics? So in particular, new people, but also new students that are deciding about selecting the topics about electronics, about power electronics with wide band gap.
That's a great broad question. When I was back at school, at high school, thinking about what to do. I was actually part of a theatre group, and I was on the lighting and sound side of that, just through school, the high school stuff. And I actually wrote in pen on a
Mm.
letter back in the day to a company that did the light and sound, and they recommended that I do electronics if I wanted to get into that. So I think the first thing is do what interests you, do what you love. And I think going through that, you take advantage of the things going around you as well. Like when you're a student in the UK, you join the Institute of Electrical Engineers, the IEEE, and then you stay with that, and you bring in additional things. So even though I was at Manchester, I was working with students from Cambridge, from Oxford, from Nottingham, all of these different engineering places. And if you can keep going with that, if you can keep reaching out to different organizations, join the societies outside of the university. Number one, it gets you to travel. Even if it's just a 2-hour train ride, it's a place to open your mind. And then later, as a student, submit as many papers as you can to these exhibitions like APEC, PCIM, because that means if you're accepted, then they have to pay for you to travel over there. And it's just broadening your mind. And just like the infrastructure, Navitas pushing ahead with new technologies, the GaN on silicon, silicon carbide, looking at new things like digital fast isolators as well. Look wider than you're currently focused on. Put in the extra effort to think, what am I driving downstream? What kind of battery is it? What can I bring to the table to really, stretch out? So I would say make as many friends as you can in parallel, sideways industries and groups. And once your brain expands, you can see the different figures, the different value propositions in those areas. It improves your work. It also means that you get asked to join new companies to promote your career. That's an incredibly valuable thing. It's a lot easier to be asked to go to Los Angeles than it is to apply for a job in Los Angeles. It's a big difference. So try and get out there, try and make friends, learn more about the broad industry, and look ahead.
Great. Thank you, Steven. I loved your conversation. Thanks a lot for your time. Have a good weekend, and see you next. Thank you.
Thank you very much, Maurizio. It's been a pleasure. Bye to everybody.
Bye.